Here's another update for Kitsune OS. So not only is there the cycle counter on the processor itself, but on the Raspberry 4 system on chip, they have a system timer, and you can read that from a particular part in memory, and I have that hooked up to T. So if you just keep hitting this here is the system timer, and you can see it slowly or fast, depending on which digit you're looking, incrementing up. And this is independent of whatever the clock speed is, which I found out. I did some calculations. Right now it's 600 megahertz, which is the default and the slowest the Raspberry Pi processor can go, but this is independent of the clock speed. The other thing is we have interrupts working. So to do that, you've got to hit Q first, and this Q toggles interrupts on and off. Whenever you see the D here, that D represents 2 bits that mask out IRQ and FIQ, which is the interrupt and fast interrupts. And then when you have the 1 there, those bits are off, meaning they're not masked, meaning that it's going to let them in. So first we unmask those bits because they're masked by default. Then I hit Z. That enables the IRQ for the system timer in the GIC 400 interrupt controller. That's also on the Raspberry Pi 4. And then you also have to set another set of bits on that same interrupt controller, which tells the interrupt controller which CPUs to send which interrupts to. So in our code, we simply send it to the first processor, because that's the only processor that's running. So once both of those are set, I've got a couple commands that I can actually set a time on the system timer. When the timer hits that time, it'll fire an interrupt. So if I hit the C button, it's going to set an interrupt and set the time for 3 seconds. 3 seconds passed, and we got our interrupt. And when the interrupt fires, you've got to do a few things. First, you need to check the interrupt controller. There's a register there mapped to memory, and it'll tell you what interrupt ID you got. And in this case, it's let me look at the source code. Let's put it in here in the window. So it's going to be 96 plus 1. So the interrupt is going to be 97. I'll show you our code here that handles the interrupt. So we just print this IRQ string to the output. You can see that here. And then this is where we're getting the interrupt ID. I call these two instructions to set the address to FF84200C, and I just load that into register 0. And then we clear timer 2, because once the timer 2 trips, we've got to clear it so it doesn't keep firing. And then we need to tell the interrupt controller at a slightly later address. Yeah, it's exactly one word later. The end of interrupt register, we say, hey, we handled this. And we do that by writing the interrupt ID that we got here to that register map to memory. And then we print our end of interrupt request string. And so we can do this multiple times. If I hit C again, it'll fire off in another 3 seconds. Yep. Just keep doing it. It is pretty glitchy. I think I'm like missing something. I'm finally getting into race conditions and stuff here, and I'm getting into race conditions at a very low level. So I think this breaks sometimes under very specific conditions. So I'll have to make a more robust interrupt handler in the future. But now that we have interrupts, we can respond to data coming in through the serial line. So when I hit a key on the keyboard, it'll trigger an interrupt, as opposed to us just pulling. We can do other stuff instead of just pulling the UART line all the time. So now UART can be driven by interrupts. We can set up scheduling and do multitasking. and have the timer go off at every set interval and switch between tasks and do stuff like that. So yeah, I'm pretty excited about this. And the next thing, I'm not sure what I'm going to do next. I might try playing around with some more video core. I found some of the documentation for the video core. I also need to figure out how to do professional memory allocation and memory management. I'm probably also looking into using the memory manage unit, the MMU, because right now it's disabled for all this code. So I'll probably start looking at that next.